Hola amigos! Today I bring you another tutorial inspired by the Spiderverse movies. When combined with the effect from the last video, this post-process material can produce really interesting results. We'll make everything configurable so you can adjust this to your project needs, from the texture scaling or the blend opacity to the amount of video glitch overlays and amount of color swaps. We have a lot of stuff to cover today, so let's get started by breaking down the effect from the movies using some screenshots and other promotional materials. As I mentioned in my previous video, the Spiderverse movies feature a lot of different art styles, and personally I think that all of them are really cool. But today we're looking at the glitching, so let's take a look at this set of images and try to figure out what are the common elements between them. Let's zoom on this spider, for example. The most defining aspect of this effect is that the render is segmented using some kind of arbitrary polygons. Like we have this one here, let me pick a different color, then we have this one here, and another one, and so on, right? And of course, in the context of the movie, the idea is that all of these are different parts of the same spider from different universes that they are all colliding here. And to make the effect even better, in the movie sometimes they replace the entire mesh or parts of it with a different one that can be completely or just partially different. And we could achieve that part possibly using different render targets and swapping them, or having a different pass for characters that need to be glitched out or something like that. But today we're gonna look at just the post-process part of this. So let's try to figure out what can be done in Unreal. For starters, another obvious thing is that we have some kind of overlay texture happening here. Like here and so on, right? And if you look at this in motion, it seems pretty clear that it's either some TV noise static or some kind of video glitch, and sometimes they swap between something that looks more like VHS noise and sometimes more like just an image of an old CRT screen or something like that. Next, we have some kind of misalignment or offset of these pieces. Like if we look at the legs, which are pretty easy to identify, we see that they are not aligned, or these pieces are not aligned. Like this red one is offset like that, and this other red one is offset like that, and then here it's offset, I don't know, like this, and here we have an offset like that, and so on. So also the offset doesn't seem to be constant, it's randomized or random per piece. Cool. Next we have some kind of color treatment. Like we have these brown legs and then red legs, and then sometimes the static is more blue, like on these ones, and sometimes it's more green, despite I think being the same texture. Cool, and I think we can do all three of these pieces in Unreal. And if we look at any of the other images, they seem to have a lot in common with this. So I think that this will be a good start. Now let's go to Unreal and make it happen. This is the same scene that I used on the previous video with a post-process volume that has already been set to unbound. So let's create a new material to add. I'm calling this one glitch tutorial. And before we can add it, I need to change the domain to post-process, and I'm going to also change the blending location to before tone mapping. Now, so we don't have a black screen when we press play, let's add a scene texture. And just for now, we'll change the ID to custom stencil. And from my previous video, the character already has been set to be rendered with a custom depth pass. So we hit apply and save. Now we can assign our material here. Let's find it. This, and if we press play, there is our character. Cool. Now let's bring out those that segmentation effect first, so we can create a mask that we can use. And for that, we're going to use these textures that I made in Substance Designer. First of all, we have this triangle boolean, which is just a bunch of triangles, and the intersections between them are colored randomly. Next, we have the classic Voronoi distance, which where each area is the area that is closest to a point. And finally, we have this one, which is also a Voronoi partition, but using the Chebyshev distance measuring method, which produces this kind of blobs. And I thought it would be interesting, so I include all three of them as a download on the description. So let's bring those into our material. Now, we might want to change this texture later, so let's use a parameter. Shape texture, for example. Let's change this one. You need. Let's start with the Voronoi one. Okay, so after that, we need a texture sampler. Let's connect the texture, and we might want to scale this texture, so let's do that. Taking the default texture coordinate and multiplying that by a parameter. We can call this one shape texture scale, and let's keep it at 1 for now. Let's pass those coordinates and let's look at what we have. Cool, now we have a texture, and if we change this value, it scales, and we can make it smaller. Perfect. Now, each one of these random colors has obviously different values for red, green, and blue. That produces the random color. So now let's take these colors and separate just the red and green components. And now we can take those green components and add them to default texture coordinates. So let's connect it like that, so it's a bit cleaner. And now let's pass those to our custom stencil and see what happens. Apply. And well, something's happening, and yeah, there is our character, but everything has been distorted a little bit too much, right? So let's balance that out by going to our material, and before we add these values, which are coming from the texture, let's multiply this. And we're going to add another scalar parameter, and we call this one shape offset scale. And let's keep it very small. Let's do 0.05. And now let's reconnect it to the add. Apply, save. I want search and press play, and perfect. Now this starts to look a bit more like the result we want. Our character is there and it's still identifiable. There are the hands and the legs, but everything is a little far away, and you can see that these are defined by these polygons. Cool, we can even go to our material. Let's change the size of these and rearrange things a little bit. And we can try scaling the texture up if we want more triangles or more shapes, like that. or we can change the texture object that we're using and try the triangle wool, for example. This one maybe resembles a little bit more what we see in the Spider-Verse movie. Perfect. Now we can bring back the color from the image. So let's bring back the editor and add a comment here just to keep things clear. So now for the color we need another scene texture, so we can copy this one and change the ID to post-process input 0. Now we can give it the same UVs that we used for our custom stencil, and let's try it out. Okay, so now the whole scene is affected by this distortion, but we just want the character. So let's bring back, or let's bring another copy of our scene color, but for this time we won't use the distorted UVs. So as you might imagine, it's just the original scene. So now we can use a linear interpolate or lerp between this image without the distortion, the distorted one, and use our custom stencil as the alpha. Now connect that to the emissive and hit apply, save, and there it is, our color and our character and the distortion. And as I mentioned earlier, if we didn't want to see the character, or even if we wanted to replace it, then we need to replace the character and render it separately and then composite the image, and that will be a whole tutorial by itself. So let's keep it there, because with all the animation and distortion that we'll add later, I don't think that will be a problem. Now another thing that we can add here to have more control over the effect is a parameter to control how much we want to blend this with the original color. So let's add a multiply. Oops, not a mask. A multiply. And multiply the custom stencil or mask by another scalar parameter, which we can call blend opacity. And if we keep it at 0, now our effect is gone, and if we increase it, now the effect is there, and at 1 our effect is fully opaque. Cool. Now we can move on to the next part of the effect. Before we add more layers to the effect, you might have noticed that this is offset to the left and up, and is not centered on the character. That is because all the colors that we are sampling here are values between 0 and 1, but we can center those if we just subtract here before we scale the values. We can just center that by subtracting 0.5. I don't think we need to turn this into a parameter, but you can if you want. And here we have, now the effect is centered on the character. Perfect. So now we can talk about animation. Now we are sampling the texture here, and we could pan this, and we are sampling the scene here, and we could pan that. Now if we move the triangles, actually we can add a panner here and give it a try. So let's add this to multiply, give it some speed, and now the triangles are moving, but if we pause and go frame by frame, sorry, there we go. Now the color information inside each of these shapes is not really changing, so it's just the mask that is moving. Now if instead we pan this, or we move this after we sample the triangles, so we reconnect this And let's say now we pan these values. Now the triangles stay in place, but it's the color that is moving away. Now we are going to animate each one of these parts independently. So let me remove all this. Make sure that everything works as intended. Perfect. Now for the triangles, I want them to change every now and then, like, I don't know, once every second or half a second, like boop, boop, and they change again and again and again, something like that. And I don't care where they change, I just want this texture to pan somehow at some interval. But for the image, I want it to wiggle around, and you saw what happens if we just pan it in one direction, it just goes away. So that needs to be centered around some point. You could animate each one of these manually using curves or some other method, but let's try to do it procedurally. Let's start by panning the texture. Remember, we're going to pan the shapes. So we need a time, and let's scale this so we have some control over the speed, and we'll give it a parameter for that. So shape movement interval, and now let's take the floor of this number. So now our time goes 0, 1, 2, 3, etc. And now let's scale this again by multiplying, and this will be the amount that the texture will move on each interval. So let's do 0.1, and now we just need to add it to our coordinates. And let's hit apply and save and see what happens. Perfect. Now our texture is changing every 2 seconds, and if we change this number here, or sorry, to 0.5, it should change every 0.5, and if we do 0.1, cool. Now it starts to look like more like a glitch. Perfect. Let's animate the contents of these shapes next. Let's add some comments here and there to organize things a little bit. So this would be our shape texture panning, maybe, and this area over here would be our final blend. And now we can make a little bit of room, and so instead we're already moving the contents of each shape in a different direction. So really what we need to animate is kind of this value over here. We just need to scale this displacement a little bit over time. So let's start by taking the time and scaling it up. So we need another parameter, and let's call this one wiggle speed. Cool. And now we can add that to a texture coordinate, but instead of sampling the whole texture, we're going to sample a single point. So let's add a constant to vector, and any point we do, so we can keep 0, 0, and now add a texture sample, and I'm going to use one of the noises that comes with Unreal. Let's search for noise and use the game wind noise. So now we're sampling the first pixel in this texture, so this one over here, and over time we are moving, actually we're moving both coordinates at the same rate, so we're sampling these points over time. And if we use both channels, basically we're using this line of coordinates. So now we can take a component mask here, and now I want to center this, but unlike here, which I didn't care if the range was minus 0.5 to 0.5, I want to keep the full range here. So let's first multiply by 2 and then subtract 1. So now these numbers go from -1 to +1. And now we can just multiply this here. And reconnect. And just to make sure that we see the effect, let's increase the interval to, I don't know, 100 seconds. So let's hit play, and yeah, now everything is wiggling a little bit. Now we can increase the scale. Let's see, 0.1 just for now. Okay, so now the triangles or the shapes are not moving, but the contents are. And they are not moving too far, they are still just wiggling a little bit back and forth. So now let's play with these values and combine everything. So let's go back to 0.1 here, and then I think this can go back to 0.05, and let's speed this up maybe to 2. Cool. Yeah, I think this looks pretty cool. Okay, so next step will be to start manipulating the colors of this image. First I want to add a comment here, so let's select all these nodes and call them wiggle. And now color. We can do a few different treatments, so let me make a bit of room, or actually we can make a couple tests here. First, let's say we want to just, I don't know, invert the colors. So the easiest way to do that is with 1 minus. We can saturate, or actually let's do a max 0, so we can keep all the high values but nothing negative, and reconnect it and see what happens. Hit apply. So yes, our colors are inverted, and especially if you get a lot of lighting around the character, you get a bit more contrast. But our image is very dark, so the result tends to be very bright. So you can tone that by multiplying these colors first. Let's say multiply by 10. Hit apply. Yeah, and now there's a bit more contrast. Everything is a bit more visible. We can see more colors. But this is not exactly the effect I'm looking for. You can use this in your project if it works for you, but I don't really like it. Colors. So let's move this one to the side and see what else we can do. Well, these shapes that we are using to distort the image have a color, and it's a unique color per shape. So if we take the RGBA and simply multiply that by our original color, actually, just for cleanliness, and reconnect this to our lerp. Let's see. Well, yes, it would be easier to see if we pause the thing. Okay, so now each shape has its own color, but remember, this texture has all sorts of random colors, and some of them, let me open it, here for a moment. Some of them are pretty dark, like this blob here, or these ones, this one, this dark green here. It's actually not very bright either. It's saturated, but pretty dark. So when we multiply that by our base color, we get these patches that are pretty dark and don't really show the effect. If that's the style that you're looking for, again, feel free to use something like this. You can also, I don't know, divide the colors or subtract them, and try different operations and see what could work better for you. Now, what I want to do is something different. Actually, let's remove this. And I want to do a hue shift. So we can add the node hue shift, and it says texture v3. So we need to component mask this first to our RGB components. And now for the percentage, let's take the time and just multiply it by a factor. Let's say multiply and add a scalar parameter and call this hue shift speed. Let's keep it at 0.5 for now and connect it to our shift percentage. Actually, let's make it fast just to see the effect a bit more. And we can now replace the result in our lerp. And we get an error because we have a vector 3 and this specs is vector 4. So we need to append another component. So append vector, constant, and reconnect. So just to summarize, we're multiplying the time, scaling it up, and using that as our hue shift percentage, and the image that we're shifting is our post-process input 0, and then at appending, we're appending a 0 just to make sure that we don't have an error by mixing vector 3 and vector 4. Cool. So now this is colorful. Now we have a disco party here. And the good thing about this is that because we're shifting the hue and not multiplying or tweaking the colors in that way, we keep all the original lighting and all the original shadows. We're just tweaking the tones. Now, let's combine that with the previous example and make that change in the hue different for each one of the shapes. And we need only one of the components for that. And let's say we're using the red and green, so let's take the blue and add that to the time before we scale it. So we take the time and add in the blue component from this texture sample with the shapes, and now connecting that back to the multiply where we are scaling it. Perfect. Now hit apply and save, and there we go. This is the result that I think looks closer to the movie. So now each shape, it has its own color, and if you make it fast enough, or depending on the timing that you're using, you can see some hue shift before the shapes change again. And because all this is meant to be a glitch, anything that makes the effect a bit more chaotic, it's probably a good addition. You could also combine this with the invert colors if you want, using a separate mask to choose some triangles. But we're not going to do that for this tutorial. So let's add a comment and call this one hue shifting. Cool. And next, okay, let me save. Next, I don't want the effect to be applied to all the shapes. I want some control over what percentage of these blobs get affected by the hue shift. So let's see how to do that next. Now that part will be a bit easier to do. Let's take a look at our texture for a moment. I'm going to remove some of the components. So let's say we define a threshold, for example 0.5, and we say, well, all the blobs whose green value is higher than 0.5, include them in this new mask, and all the values that are lower than 0.5, remove them from the mask. If we now change the threshold, that will basically give us a percentage of how many of these blobs are included. So let's do that using a step function. So I'm going to take the green component, but you can usually also easily, I don't know, do the average of the other two or something like that. So add a step component, or sorry, a step node, and let's make some room, and let's do the step again of the green component against a new scalar parameter that we can call shifted hue shape amount maybe, and just for now we'll keep it at 1. Okay, so now we have a mask. Let's apply that, and for that we'll use another lerp. So the mask goes in the alpha as always, and let's see, for the first component we want the untouched scene color, so let's connect that to the A. And for B we want the hue shifted color, which we have here on this append, so let's connect that to B. And now we need to replace the original B on the final blend. Let's organize things a bit, hit apply, save, and see what we have. Now it's still set to 1, so let's reduce this number and let's say 0.5. And now we have less blobs. Let me pause for a moment. And the rest of them, like these ones here, are keeping the original color. They're still distorted and they're still shifted around, but they are not getting the hue shift applied, which is exactly what we want. And you can even decrease this value a bit more if you want less of these colorful things, something like that, or go all the way or the opposite way, like 0.8, and get a lot of these. I think that maybe 0.2 or 0.3 work well. And let's say the motion. Yeah, I think this looks pretty cool. Now we just need to give it a comment, or not really. It's part of the hue shift, so I'm going to just include it here. And for the final part of the tutorial, let's add this texture overlay on top of some of the different set of cells. For that, we're going to need a texture, so let's start by adding a texture object parameter. Texture object parameter, here it is, and we can call this overlay texture. Now, let me search. I downloaded a couple glitch textures from the internet. Let's see them. These won't be included as downloads in the description, mostly because I haven't made them myself. But if you Google search for video glitch texture or image glitch texture, there's a lot of stuff like that. It's perfectly fine to use. So there's one, and this is the other one. And we can use either of them. Let's stick with, I don't know, this one. So we can now sample that. And for the coordinates, let's start with just taking the default texture coordinate and scaling that. So multiply by a new scalar parameter, which we can call overlay texture scale. And for now, let's do, I don't know, 5. Connect that to the UVs. And now, how to blend this with the color? There's a few ways, and we could do something like the overlay from Photoshop, which basically reduces the image to a grayscale and then applies a different formula based on the brightness. And we could also do just a multiply or divide or add and subtract. But I think that with this image that has a lot of contrast, we can maybe do a maximum. So let's take the color and do the maximum between that and the RGBA of this texture. And for now, let's just connect it to the lerp here and replace this and see what happens. So now our texture is applied to the whole model, but since we're using the maximum, all these dark areas are barely there, and we have a lot of, I don't know, interesting detail in these shapes. But there's a couple things that we can improve. The first one is that obviously this is still mapped to the whole screen, and it's very constant, very uniform. So let's move these UVs a little bit, and we can, before we scale them, let's add the center UVs that we are extracting from this texture. So here, they subtract, let's bring and add them. You can control drag to take existing connection somewhere else. So we are adding the UVs sorry, to the texture coordinate, and then scaling that, and then using the maximum of that and the color. And now, cool. Now each part of the texture that we're sampling is sampled from a different part, so they are not matching anymore, and each one of these blobs is slightly offset with respect to the rest. Cool. Okay, the next thing that we can do is that, if you have noticed, this glitch is not color shifted. Like, we can go back here and actually let's increase the amount of shifting that happens to make sure that all of them always hue shifted. And now we don't have the glitch. Okay, that is because if we trace the hue back all the way to the hue shift and to this component mask, well, we're still affecting the hue from the original image. So let's see what happens if instead of this input, we connect the max here. So let's do that and then connect it to the component mask. And now we have our glitch and our color hue variations, and they are affecting each other. So we zoom in, we can see that now each part of this, it's tinted, but it keeps the texture on top. Perfect. So then the last thing to do to finish this part is to add a step so we can blend this properly. Same thing as we did earlier, we are adding a step with a parameter, and we can call this one overlay shape amount, and actually let's keep it at 2 so we can see, or let's do 0.5. And now for the other input of this step, we are not using here the red component, so let's take that one and connect it here. Now, to blend all this together, we're going to need a third lerp, and this is going to be our final one. So let's add a linear interpolate, and the step is the alpha, just as we did before. And now for the first input, we're going to take the color without any changes, just the distortion. For the second input, we're going to take this maximum, which is the overlay texture on top of this. And now we just need to replace the connections that we had originally. So first is this one, and next is the one on the component mask. It's a bit messy, but I hope that you got everything. Feel free to rewind the video and go slower if you have to. So let's hit apply, give this a comment. And see how it looks. And this is the final result I ended up with after some tweaking of the parameters. The only thing that I changed while you were not looking was, let me open the material again, and here on the wiggle section, I added this power between the component mask and the part where we center the coordinates, with a scalar parameter to control it. This basically allows us to reduce the mid-tones of this texture. If you remember, it's a soft noise, so we can control how much contrast it is. And by increasing the contrast and eliminating these mid-tones, we cause the movement to be, instead of a more flowy version from one side to the other, to just more snappy, like it's either on one side or the other. And let's test it out and see the effect it has. So if we reduce this to 0.1, now it's hard to see, but now this distortion, and actually let's reduce the speed and increase the scale so it's easier to see. Now you can see a bit of the motion, right? On this distortion, you can see these pieces go from one side to the other before they change. And if we increase this power, now all this movement, or a lot of this movement, disappears, and they are just either on one place or the other, but kind of not in between. Now we can go back to a more reasonable scale and tweak this speed, and that's it. And we can take a look and see how it looks when combined with our other post-process from the previous tutorial. Let's see, I have it here. Let's increase that, and this actually looks pretty much like the start effect on the Columbia Pictures logo that we were looking at earlier, or some of the shots from the movie. So I think that will be all for this tutorial. I hope you guys liked it, and if you did, please consider giving a like and subscribing if you want to see more content like this. See you next time!